the next topic is the official gas laws. And again, you don't have to memorize the formulas, but you have to know the relationship between the variables that we are going to discuss here. So you're gonna know the relationship between pressure, temperature, volume, and in when we return from winter break, we're gonna talk a little bit about the mole. But we're not gonna talk about it during the winter break, so not yet. There are 5 laws that you're gonna understand. Formulas will be given to you. You don't have to memorize them; just know how to use them. And honestly, they're not that bad. Um, it's not as complicated as the stuff that we've done in the past. So the first one that we're going to focus on is called Boyle's law. Boyle's, the way I remember it is Boyle's has nothing to do with temperature. So temperature remains constant. It remains the same throughout the entire experiment. In Boyle's law, we only deal with pressure and volume. For example, in this demonstration here, if you seal a syringe and you put a marshmallow inside, when you add when you decrease the volume by pushing on the piston, so you push it in, the decreasing the volume would increase the pressure, causing the marshmallow to shrink. But if you expand the piston, you move the piston outward, then the marshmallow gets bigger and bigger and bigger. So we start to see this relationship between pressure and volume. So Boyle's law again has nothing to do with temperature. It shows the relationship between pressure and volume. You could think of it as a hot air balloon. If you keep the temperature of the hot air balloon the same and you play with the pressure, then you will eventually change the volume of the hot air balloon. So here it is, Boyle's law. Nothing to do with temperature. And shows the relationship between pressure and volume. So if you increase the pressure, then the volume decreases. If you increase the volume, then you decrease the pressure. So they're inversely proportional, meaning that when one goes up, the other one goes down, and that's represented through this formula. P1 V1 equals P2 V2. So the 1 stands for before and the 2 stands for after. So let's say we have a balloon and it has a certain pressure. Let's say it's 1 atmosphere. And the balloon has a certain volume. Let's say it's 1 liter. But then you sit on the balloon, so you're increasing the pressure. So you're changing this. What is going to be the new volume? So if this pressure goes up, then theoretically the volume should be lower. So we have to think in that sense. When one thing goes up, the other thing goes down. Okay, so just think about that. When we increase the pressure of the syringe here, the volume decreased because the marshmallow shrunk. But when you have less pressure, then you'll have an increase in the volume of the marshmallow itself. So you start to see this relationship that's inversely proportional, and when it's inversely proportional, you see a curve, because if you notice, when the pressure goes up, what happens to the volume? It goes down. So when one thing goes up, the other thing goes down. Okay, this is called inversely proportional. So that's the theory, but how do you do the math? And the math is actually easier to do than the concept. So here's one example. So this question, it says a balloon. So a balloon has an initial volume of 1 liter. So the initial volume is 1 liter, and the initial pressure is 1 atmosphere. When you sit on the balloon, the volume decreases to 0.5 liters. What is the new pressure? So the first thing you need to know is, what formula am I going to use? So far we only learned one, Boyle's law. So Boyle's law says that pressure and volume are related when everything else, such as temperature or moles, n is moles, is constant. So we're going to use this formula. So we're going to look, okay, we're going to identify the variables. A balloon has an initial volume of 1 liter. So that means V1 is going to be 1 liter. And the pressure is going to be initially at 1 atmosphere. It says when you sit on the balloon, the volume decreases to 0.5 liters. So V2 is equal to 0.5 liters. What is the pressure after you sit on the balloon? So that's going to be P2. Now you're going to use the formula and you're going to solve for P2. So P1 V1 equals P2 V2. We want P2. So we're going to isolate this, and the way we do this is we get rid of whatever's next to it by dividing, because they're multiplied, so the opposite of multiply is divide, so V2, and then you start plugging in. So what is P1? P1 is, I'm going to put that down here, P1 is 1 atmosphere. Make sure the units are the same. V1 is 1 liter. And V2 is 0.5 liters. So again, they make sure both units are the same. So liters, liters, milliliters, milliliters, centimeters, cubed. And they're going to cancel the liters, and you'll end up with atmospheres, which is P2. And when you solve this, you get 2 atmospheres. So, does this number make sense? So look, the volume went from 1 liter to 0.5. So the volume went down. So we know that according to Boyle's law, when volume goes down, the pressure should go up. And look, does it? It went from 1 atmosphere to 2. So this makes sense. By decreasing the volume, we should get a higher pressure. And so circle higher. According to Boyle's law, and we do. So this makes sense. Our answer makes sense. I'm going to try. I'm going to try the first example of the next one, and then has to be a faster way to erase this. Come on. Okay. So I'm going to try the first one. You're going to try the other 3. So again, we're going to read the problem. I know it might look a little scary, but it really isn't. So it says a gas has a volume of 2 liters and a pressure of 1 atmosphere. What volume will the gas have at 4 atm? So what we're going to do is identify the formula that this corresponds with, and we're going to choose the Boyle's law equation because the question involves pressure and volume, and because it doesn't mention temperature, we're going to assume that that is constant, okay? So I'm going to do it up here. So a gas has a volume of that. That's going to be V1. Pressure of that. That's going to be P1. What volume will the gas have at P2? We are looking for V2. So it says what will the volume be? So it's implied that it's V2. So when we're solving for V2, because that's what the question says, what is the volume at 4 atm? So P1 V1 equals P2 V2. We're solving for V2. So whatever is next to it, we divide and we put that on the other side. And then you're going to plug in your number. So P1 is 1 atmosphere. V1 is 2 liters. And then you divide by P2, which is 4 ATM. Notice how the pressure units cancel. And you're left with liters. And when you do the math, 2 divided by 4 is 0.5 liters. Okay? So go ahead and pause this. Reflect on what we did in example 1 and this practice problem number 1 as well. And then see if you get these answers for 2, 3, and 4. So go ahead and do it. See if you get these numbers. So for number 2, you should get 0.212 atmospheres. For 3, you should get 40 liters. And for number 4, you should get 4 atmospheres. Okay, so see if you get that. Okay. All right. Okay, so now that you're done with those problems, there's some more problems here, but we're gonna do these together as I want you guys to try it out first. So I want you guys to read through these 4 questions and using your notes. I need you guys to look at your notes and answer these problems. See if you could get them. Okay, once you're done, press play. And I'm going to go through them, okay? Alright, so I'm assuming you already did the problems. Now let's go through them. So the first question says, what is the coldest temperature possible? So that would be absolute 0. So that's going to be 0 Kelvin. Or you could also say negative 273 degrees Celsius. What happens at this point at absolute 0? Motion of particles stops. Okay. Number 2, what are the temperature and pressure at STP? So standard temperature would be 0 degrees Celsius or 273 Kelvin, while standard pressure is 1 atmosphere. 3, what does Boyle's law state about the relationship between pressure and volume? Let's say when volume goes up, there's a decrease in pressure, or vice versa, and we say that they're inversely proportional or indirectly proportional, okay? Indirectly proportional. For number 4, it says a sample of gas in a cylinder has a volume of 10 liters. I'm assuming that's liters. So V1 is 10 liters. And a pressure of 3 atmosphere. So P1 is 3 atmosphere. What is the new volume, which is V2, when the pressure is decreased to 1.5 ATM? So what you're going to do is you're going to solve for V2. So P1 V1 equals P2 V2. And when you solve for that and you plug in your numbers, once you plug in your numbers, you should get 20 liters, okay? That's what you get once you plug in everything.